a micro post on microcentrifuge tips and tricks. So microcentrifuges are these little things that we can use to spin microcentrifuge tubes. We often call these Eppendorf tubes really, really fast. And so here are just some quick tips and tricks for working with them. So first of all, you always want to make sure that your centrifuge is balanced, but it might not necessarily look balanced. So basically the easiest is if you just have like an even number of samples, you just stick them like straight across from one another. It's really helpful in these ones if you just have two samples where they have like a line across from some of them. So you just want to make sure that they're directly across from one another. You can also count the number of tubes in between. So that stuff works great if you have an even number. What if you have an odd number of tubes? So if you have 3 tubes, or you have like some multiple of 3, you can spread them out in like thirds, and that'll still be balanced. Okay, well, what if you have 5? So this is where it gets a little weird looking. So if you have 5, say you have 3 already in there. And then so that's balanced, and now we remember that we can stick 2 tubes across from one another and that'll balance. So we can stick these tubes as long as we're making them across from one another. We can then stick these tubes across from one another, and it looks really funky, but it's actually balanced. If you are using a centrifuge and you have like permission to do so and stuff, you can actually make marks on the thirds and that sort of thing if you have trouble keeping track of which is which. Speaking of balances, so if often I hate when you're doing like mini preps or something, or some sort of purification, and you have like some weird odd number of tubes that you can't use like a simple trick for. Balances come to the rescue, even too if you're just like too lazy to try to figure out which combinations will actually make your thing balanced. But so we often keep just like a rack of blank tubes. It's really important that, so we have ones with different weights and stuff. Sometimes you'll see people have like written on the outside like how much is inside. So this is like 440 microliters. If you're doing something where it's really important to be super duper balanced, like if you're going really fast, or if you need some sort of really balanced thingamabob, sometimes it's not as crucial if that you have like a perfect balance. But it's important to like mark that it's a balance. So sometimes people just have tubes here and it's just like an old tube that they're using as a balance, but it has some random stuff in here. Some of these aren't labeled at all, which is never a good idea for tubes, but what's important is that you have like some sort of X or something to mark that it's a balance, as well as labeling the tubes that you put in there. So I talked about labeling the other day, but it's really, really important, even if you're just doing a quick spin of something, especially if you're using a blank and that blank isn't labeled. So I had this happen once where I was really tired and rushing, and I hadn't labeled my tube because, I was just doing a quick little pulse spin in one of those like microfuge things, which is like this, but it's really small, and you just do a quick pulse spin, and you can't control the speed and stuff. But anyway, I didn't have my tube labeled, and the blank tube, I just like found a tube. I'm like, oh, let's use this as a blank really quick. The blank tube wasn't labeled, and then I spun it, and then I was like, oh, which was my tube? So don't let that happen to you. Thankfully, in that case, I could figure it out because my tube was cold and that one wasn't. But you don't want that to happen to you. Okay, so that is the deal with blanks and stuff. How about the speed? So speed can get really weird, because often, so here it's nice in that it's like times G or RPM. Sometimes you'll see it as like RCF or RPM. So RCF is the G force, and so basically RCF, relative centrifugal force, it's telling you like how much force is being applied when things are getting spun down. And so it has to do with the RPM, so the rotations or revolutions per minute, as well as like the radius of the centrifuge. So how far your sample is from the center. So the further out it is, the bigger the force that's going to be applied. The faster it goes, the more RPM, the faster it's going to be going. Often your protocols are going to give you things in the like something G, like 12,000 G or that sort of thing. So the G is referring to that it's the force in relation to the force of gravity. And so that's where the times G comes from. Often protocols are going to give you the things in terms of the G because that's going to be, if you have if your centrifuge has like a slightly different rotor or that sort of thing with a different radius, you can still directly compare the RCF or this G-force, which is what your sample is going to be feeling. But when you're setting it, make sure that you have the setting to the appropriate thing so that you have it on the G or you have it on the RCF. Remember, that's the same thing if your protocol is based on that. So sometimes it'll accidentally be on like RPM and you're setting the setting and you're setting it wrong because then they aren't going to be the same. So for example, 13G, if we go to RPM now, it's 11.6 RPM in this centrifuge, but it would be different in a different centrifuge. Going back to the idea of that centrifugal force, when the force is applied, basically your sample, if your sample is like pelleting and stuff, the pellet is going to be right where my pinky is. So on the top outside, so it would be like at the top of my elbow if my arm were the tube. And so when you are pelleting something, especially if you're doing something where the pellet's going to be really small, like maybe you're precipitating some RNA or some DNA and you're going to have this really small pellet, you want to make sure that you're able to like know where that pellet is so that you don't actually just like suck up the other stuff. So what you want to do is, I like to angle the tubes, always add them in like the same direction. So I put them so that the little like this part is like up here. And this way, when I take the tube out, I know that the pellet is going to be directly down from this little ridge of where the clampy, hingey thing is. You can also like mark it on the outside of your tube when you take the tube out. Speaking of when you take the tube out, if you're taking the tube out, you want to take it, be really gentle, like take it out at an angle and then take your sample out. So it's helpful if you do this like one tube at a time rather than taking all the tubes, sticking them in your rack. Now the pellet's gonna like potentially like unpelletize. If you keep, because you're like agitating it, you're like walking around to your bench and stuff. So if you bring your pipette over and actually remove the liquid, the supernatant, before you do that, that can be helpful. Also with DNA and RNA precipitation, there's this thing called like glycoblue, which is like this precipitating agent, has like glycogen, which is going to help like pull down the DNA or RNA and precipitate it. And it also has a blue label, so you can see it better. So that can be really, really helpful too. So some of these microcentrifuges have like a refrigerant in them. Often they have some sort of like quick temperature thing setting. Sometimes it's not so quick though, but that's where it does a spin like before to get it ready to the right temperature. And so you want to make sure that's actually at the right temperature before you use it. If you need something to be at like 4C, it might not currently be at 4C, it's just set to be at 4C, and you want to make sure that it really is, and you can also like feel inside of it to make sure that it is. You have one of these cooled centrifuges, you want to keep it cold. You want to keep it closed. If you keep it open, then what's going to happen is it's going to like keep trying to cool itself, and then it's going to like get all like weird and icy and stuff, and that's not good. It's a good idea to keep your centrifuges closed anyway so that you don't have like weird stuff flying in there. So microcentrifuge tubes are typically used with like these 1.5 mil Eppendorf tubes. But sometimes you have smaller tubes that you want to use, maybe like 0.8 or even 0.2 milliliters. So what do you do with those? So some centrifuges, they have like, they have slots in here for them. Other centrifuges, they have like adapters that you can put in, but then there are little hacks that you can do. So let's take a look at those. So if you're working with these normal Eppendorfs, you're good to go. But what if you want something smaller, say a 0.8 mil or a 0.2 mil, or maybe this is a 0.6, so it's probably 0.8 total. Anyway, you have this little tube, and you have a bigger hole. What you can do is you can cut the lid off of one of these bigger normal sized tubes, and now you have an adapter that you can use for this medium sized tube. Voila. Okay, well, what if you have a really tiny tube? Here, like one of those PCR tubes, here what you can do is you can cut the lid off of this smaller tube and you can nest again inside of that. And so here you have a simple way, if you don't have one of those adapters in your centrifuge